1. Introduction to Python. Python is a versatile, high-level programming language known for its readability and simplicity. It is used in web development, data analysis, machine learning, automation, and more. Python is beginner-friendly due to its straightforward syntax, which makes it an ideal choice for new programmers. Unlike other programming languages, Python does not require you to declare data types, which simplifies the coding process. The Python community is vast, providing a wealth of resources, libraries, and frameworks to help developers solve various challenges. 2. Variables and data types. In Python, variables are used to store data. A variable is like a container that holds information, and this information can be of different types. Common data types in Python include integers, floats, strings, and booleans. Integers represent whole numbers, while floats represent decimal numbers. Strings are used to store text, and booleans are used for true or false values. Python automatically assigns a data type based on the value assigned to a variable. This feature is known as dynamic typing, and it helps developers write code more easily without worrying about explicitly defining variable types. 3. Control flow and conditional statements. Control flow in Python refers to the order in which statements are executed. Conditional statements like if, elif, and else allow the program to make decisions based on certain conditions. For example, you can check if a number is greater than another and execute different code depending on the result. If the condition is true, the block of code inside the if statement runs. If false, it checks the elif, else if condition. If all conditions are false, the else block is executed. This structure helps guide the program's behavior depending on input and conditions. 4. Loops. Loops in Python are used to repeat actions multiple times, saving time and reducing the need for repetitive code. There are two main types of loops: for loops and while loops. A for loop is used when you know how many times you need to iterate through a sequence, such as a list or range of numbers. A while loop continues running as long as a specified condition is true. Loops are essential for handling repetitive tasks, like processing items in a list or performing a task until a specific condition is met. Loops also support the break and continue commands to control flow. 5. Functions. Functions in Python are blocks of code that perform specific tasks. Functions allow programmers to reuse code, making it easier to manage and organize programs. A function is defined using the def keyword, followed by a name and parameters, optional. The code inside the function runs whenever the function is called. Functions can return values, allowing the program to output results or pass data back to other parts of the code. They promote modularity and readability by breaking down complex tasks into smaller, manageable pieces. Functions are widely used in Python for tasks ranging from simple calculations to complex algorithms. 6. Lists. A list in Python is a collection of items which can be of any data type, including other lists. Lists are ordered, meaning the items have a specific order, and they are mutable, so you can change their content. You can add, remove, or modify elements in a list at any time. Lists are versatile and commonly used to store related data. For example, you might store a collection of student names, or a list of prices, or even other lists of data. Python provides many built-in methods, like append, remove, and sort, to work with lists effectively. 7. Dictionaries. A dictionary in Python is a collection of key-value pairs. Unlike lists, dictionaries do not store items in a specific order, but they allow you to associate a value with a unique key. This is useful when you need to look up information quickly, as the key acts as an identifier for the value. For example, in a dictionary of phone numbers, the person's name could be the key, and the phone number would be the value. You can easily retrieve, add, or modify items in a dictionary. Python dictionaries are widely used for storing structured data in many applications. 8. Modules and libraries. Python allows you to organize and reuse code through modules and libraries. A module is a file containing Python code that can be imported and used in other programs. Libraries are collections of related modules designed to perform specific tasks, such as mathematical computations, data analysis, or web development. Python has a vast selection of libraries, including NumPy for numerical operations, pandas for data manipulation, and Flask for web development. By importing and using these libraries, developers can save time and effort by leveraging existing solutions instead of writing everything from scratch. 9. Error handling. Error handling in Python is essential for making your code robust and preventing it from crashing unexpectedly. Python uses try, except, and, finally, blocks to manage errors. The try block contains code that might cause an error. If an error occurs, Python moves to the except block, where you can define how to handle the error. The finally block is optional and is used for code that should run no matter what, such as closing files or cleaning up resources. By properly handling errors, you can improve the user experience and make your code more reliable. 10. Object-oriented programming. Object-oriented programming, OOP, is a programming paradigm that organizes code around objects. In Python, everything is an object, and OOP allows you to model real-world entities as objects with properties, attributes, and behaviors, methods. Classes are used to define objects, and instances are specific objects created from a class. OOP promotes code reusability, inheritance, and modularity. You can create a class once and then create multiple objects with the same structure, but different data. This approach makes it easier to manage large code bases and build complex applications like games, software, and systems. 11. File handling. File handling in Python allows you to read, write, and manipulate files stored on your computer. You can open files using Python's built-in functions and interact with them in different modes like reading, writing, or appending. Python supports working with both text files and binary files. When handling files, it's important to properly close them after use to prevent memory leaks. Python's with statement is often used for this purpose, as it automatically handles opening and closing the file. File handling is essential for applications that need to store or process large amounts of data, such as logging systems or data processing programs. 12. Libraries for data analysis. Python is widely used in data analysis, thanks to powerful libraries like NumPy, pandas, and matplotlib. NumPy is used for numerical computations and handling arrays, while pandas is great for working with structured data, such as tables or spreadsheets. Matplotlib allows you to create visualizations, like graphs and charts, to represent your data. These libraries work together to provide a complete toolkit for data analysis, from data cleaning and manipulation to advanced analysis and visualization. With Python's data analysis capabilities, businesses and researchers can gain valuable insights from large datasets and make data-driven decisions.